So good morning, everyone. We're here to talk about metrics, alerts, and dashboards. My name is Mauricio. I work at DigitalOcean, so I work building the cloud, and as you can imagine, building the cloud is kind of complicated and requires a lot of metrics, alerts, and dashboards. So my goals in here are to show you some of what we think are the most important metrics that we should track, like stuff we should always be tracking, what alerts we should have in place. Most of the time, you should have this kind of stuff available, and what is important when you're building dashboards. So first thing is, why do we care about metrics? Like, why do we actually have to collect metrics? Why is it important for us to be doing this? Because stuff fails, right? So this is as much as it is nice for us to think, oh yeah, we're collecting metrics because we want to know if we're doing good, if customers are happy. So most of the time we collect metrics because stuff is failing, and we want to figure out why they're failing, where they're failing. We want to have the numbers to back up the decisions that we're making. So most of the time, the question that you're asking is, are we healthy? And this is what you want to know most of the time when you're collecting metrics. So they are going to be there to help you out, to help you figure out why or how stuff is actually broken in the environment. So the first metrics we should collect is any finite resource that we have. So any kind of finite resource that we have, we should have some kind of metric being collected about it. And for that, we're going to have CPU time, we have file system handles, we have memory usage, we have file system usage, we have network throughput, and many times I see people, oh wait, but aren't we running in the cloud? Should we actually be collecting metrics for all of this kind of stuff? Isn't the cloud just a magical place where you can just scale forever and you never run out of these resources? You know, no. Especially because the first time you get your cloud provider bill that's 4 times what it was in the past month, then you're like, maybe auto-scaling is not the best thing in the universe. Because you can't just it's never going to be infinite. You always need limits for all of this that you're doing, and you want to know what's happening in the environment. And most importantly, if you're doing stuff the way that's going to make you get less PagerDuty calls, you want to get this stuff distributed. You want to have it in different regions, in different environments, in different spaces, so that you can look at what's going on. And when you have this kind of distribution, the different environments are going to have different metrics. Some of our systems are distributed in 5, 6, even 8 regions, and they have different response times. They have different metrics, and sometimes we had to turn off environments because they were so bad that we're like, okay, we don't want to run this any code in here because this is not behaving as expected. So running stuff in the cloud doesn't mean that everything is just magically going to fix itself for you. You have to understand what's going on in the environment, and even if you're doing all the magic, oh, I'm doing Kubernetes, I'm doing cloud, I'm doing all the crazy stuff that's going on out there, you still need to understand what's going on these basics in your system. Because you have to understand the environment where you're running. Sometimes you're just running a bad rack. Maybe your virtual machine is just running in a place that's degraded, and if you don't have metrics to back it up to show you that this is going on in that specific place, you will never know that this is happening. So you need to understand the environment where your application is running, so you need to collect all of these metrics, even if you're running on the magical unicorn cloud that you have in there. So the other piece, once you have these metrics in place, you want application metrics. First one, operation count. So this is request response count. If you're running some kind of backend service that's just taking requests like a Hadoop cluster or something like that, you also want to collect the amount of operations that you're running. You want to know if the operations were successful, if they were degraded, or if they failed. You know, this is an example of a degraded operation, right? It did deliver. Maybe the screen that's out there is broken, but it wasn't delivered. It did go over in here and eventually found its destination. So you also want to have metrics for when it was successful, when it was degraded, and when it failed. Because you want to understand what's going on in the system. Maybe your system is getting a lot of operations, but most of the operations are failing. If you don't have this metric, you're not going to understand what's going on in there. So make sure you're collecting this. Durability. Can we find the data that we wrote? So it's great. I have metrics in my system, and I'm always getting an OK response from the database. But then when you try to reach out to the database and actually list the data is not there. So what do we do in here? You also need metrics that show, yes, every write I'm making is actually in there. When I try to find the data, I found the data that I wrote to the database. Especially if you're running all of those special new databases, you should look at this. You don't want all your data to be going to dev null, because that would not be nice. And correctness. Did we get the right data back? So when we're running in systems right now, and there's a lot of eventual consistency, you write to the database, sometimes you're not getting exactly the data that you wrote, but you're getting close. So you want to know how bad your database is. Many times we're running databases, we have multiple databases, some databases are just replicated versions of the main database, and if you go too far away from the main database, what's going to happen is that you're going to get bad data. Many times running on systems, we start to look at the system and customers are like, oh, I can't see my data. I know I have like something in here. I know I have this resource. I can access the resource, but I can't see this resource on my control panel. Why is that happening? Because they are going to a read replica. The read replica is not as close to the master as we would like to. What should happen in this specific case? The read replica needs to be removed. It should not be there. It should not be serving customer data, customer requests. So you want to make sure that you're also collecting metrics for this. You should not let a database that's too far away from the main database to continue to serve customer requests. And response or operation time. You should be collecting response, like if this is a request response application or some kind of backend application that works from queue, you should always be collecting the time it takes for all of this to happen. Like it doesn't really matter, oh, it's really fast. Can you prove it's really fast? If you can prove, if you don't have the metrics that back up the decisions that you're making, then you should be collecting all of this data. And when talking about this, we also have to talk about something that's very, very important, especially for response times. You never, ever want to use averages for this. Most of the time, they're going to give you a result that's not ideal. So these are the numbers that we have. This is just a random distribution that I produced. These are 100 numbers. So 90 numbers are from 100 to 200. And we have 10 to 1,000 in here. The average in here is 337.72. Nice, right? Not that bad. If this was like milliseconds, this is less than half of a second, so it looks okay. You know, it's not like 100 milliseconds, but it's good enough. And then we look at the metrics, and we're like, we have a lot of requests on that end, and we have the 10 requests in here. So looking at the data, we know there's something wrong in here. But can we see what's wrong from this average? We can't. The average is not going to give you this information. That's why we should not be using averages for any of this. If you have any kind of metric that you have that has a lot of variance, that has a lot of skew, you don't want to ever use averages on it. You should always be using percentiles. Whenever you have something whenever you use averages, all the outliers that you have on your metrics are going to disappear. And the outliers are exactly what we're looking for. People that are getting like good response time, like, yeah, it's good for them, but the outliers are the customers that are going to be creating tickets, they're going to be complaining on social media, they are the people that are going to give up your service and go to the competition. So you should be paying attention to this, and you should make sure for every single metric that you have that has a lot of variance, that you should be collecting them in terms of percentiles. So whenever you have something like this, use percentiles. In our case, if we went for 90% of all of the requests, we would be at 2,000. If we went for 89, then we would be at 199. So what we're looking for in here is the 2,000. That's the number that we want to know. And as you go up, and if you look at metrics, if you look at response times metrics that you have, the more you go up, the more the number is usually going up as well. And why is this important? Because those 10 requests that were taking 2 seconds, maybe that's because those customers have a lot of data. Maybe that's because we're loading a lot of stuff from the database. We're making a lot of queries. And most of the time, what it means is that they might be our biggest customers. Like these 10% in here that we're doing this, they might be giving us as much profit as the 90 other requests that we saw in the system. So when you're doing something like this, when you're collecting this data, you also need to remember that maybe these people that are really slow are the people that are paying our salaries. So make sure when you're collecting response time data, the time an operation takes to happen, you're using percentiles for this. And again, percentiles are not free. Just like Matt said on the previous presentation, as you go over the 90%, 99, and you start to add 9s to the end of this, it gets really expensive. So you have to think, does it really make sense for me to be collecting and working on this, on improving the experience for all of these customers? If it does, keep going. If it gets too expensive, then maybe you have to just think about it a little bit and say, maybe I don't want to go that far. So it's great to have these numbers. It's great to try to improve on these numbers, but you can't improve forever. So alerts, right? This is the face that I make when I get waking up 3 a.m. on a Sunday. So no one wants to get a PagerDuty call. Like, I'm really sorry, Matt. I don't want to be called by PagerDuty. I have it on my phone, but I don't want to be called ever. And it's been a while since it happened. I'm not even going to talk about it too much because it might just happen today. So the first question that we should ask for an alert is that, can we automate the response for this alert? If we can, it's not an alert. That's the first thing. Can we have an automated tool that's going to fix it? Not an alert. Don't alert if it's something that could be automated. Like, just do the automation. So easy picks for alerts that most of the time we should have in the system. Lower bounds. So imagine you're at a hospital, it's empty, there's a lot of zombies on the outside trying to get in. You need an alert for this. Like, it's empty, but there's a lot of people trying to get in. So it's just like your system is not taking any requests during the day. I mean, all of your customers should be using the system. Maybe there's something that's preventing the system, like the customers, from reaching your system. So you should have alert for this. You should know that, okay, I should have more stuff. There should be more stuff going on in my system because something might be broken in your system or on the way to your system. You should have alerts on lower bounds for your main metrics. Like, your metrics should not zero. They should not disappear. And as much as we should have for lower bounds, we should have for upper bounds as well. If traffic is just way too high, again, we can't scale forever, we can't scale up forever, we can't keep doing this forever. So make sure there is an alert that's going to tell you, oh, we are going way overboard, and we can't take this much traffic and this many requests. Going over hardware limits. If you're going over in memory, if you're going over in networking, if you're going over in CPU, again, these resources are not infinite, so make sure there is a way for you to know that something wrong is happening in your system. Maybe you're just like leaking memory. Maybe there's just something going on in your system that needs to be fixed. So make sure it's in place. And unbounded growth. If you have a file system handle leak, if you're just creating too much pressure on memory because you're not deallocating objects, there should be an alert in place that's going to give you this information before the system goes down, and you have to be alerted because the system went down. And you have to define what healthy is for your system. Most of the time, just like the SRE book, if you haven't read the SRE book from Google, just go and read the book, please. It's amazing. And you need a service level objective. You need a collection of metrics that's going to define if your service is healthy or not. And there are many ways you should, when defining this metric, you should look from a customer perspective, what does it matter for the customer, and use this to provide the service level objective for your application. And use percentiles, again, for this, please. Do not go for averages. Make sure you're making use of percentiles. For this one example is doing something like this. So I want 90% of all my requests under half a second. I want 95% of my requests under 1 second, and 99% of my requests under 2 seconds, and no more than 0.1% of failed requests. So these are the main metrics that I'm going to be looking at my application. And if I'm going over these metrics, then I'm going to say, this is not the state we want to be in, and I want to be alerted when this happens, because there's something that's misbehaving in the system, and we need to fix it. And then now, finally, you should send an alert. And when that happens, we have a bunch of questions that we should be asking. Was it useful? Like, was something actually broken when this was triggered? Again, can we automate the response for this alert? Can we create another metric to track what caused the alert so that the next time we can see beforehand what's going on and people don't have to figure out, oh, what's going on again in the system right now? Can we avoid triggering the alert next time? Is there something that we can do to prevent triggering the alert so that it's not going to wake up people like on a Sunday morning? And if you said no to all of the questions before, it's not an alert. Because you didn't learn anything, and you can't do anything. If you can't do anything, why are you alerting people? Why are you waking up people? So if there's nothing for us to learn or to do after an alert is triggered other than wake up at 3 a.m. in the morning on a Sunday, go to the machines, run a bunch of commands, and then give up, then it's not an alert. No, it's just busy work. It's just stuff that you're keeping yourself from actually getting work done, and people are going to be mad because they're waking up and they're discussing if this is a step 1, step 2, or step 3, or whatever. So do not trigger an alert if there's nothing that you can actually do to fix it. And shit happens. You know? We're building distributed systems. It is a miracle that computers work. The more you learn about networking and computers, the more you're just like, I cannot believe this is working and I get paid to do this. Because it just should not work. But it does. You know? Most of the time, at least. So stuff is going to break, and it is fine. Your system should be okay with stuff breaking every once in a while. Whenever people are just like, oh, I'm just going through alert madness because I'm getting alerted all the time, it's useless. You're not making any progress because you're getting a shitload of alerts on your phone, your computer, and getting notifications all the time. You have to understand that there is an amount of requests that are going to fail because networking issues, because you get like solar rays that hit a server and that server died. So there are many, many ways where stuff is going to break. And we just have to be ready to survive when stuff like this happens. So just be graceful when you're failing and only wake up people when there's something actually broken. And dashboards. This was one of the things that made a huge difference for us, especially for my team, is that you should not be looking at dashboards to find out if stuff is broken. This is just like the main rule for dashboards. You should not be looking at a dashboard. Is there something broken now that I'm looking at this dashboard? Like, there are no, like, this is not why we build dashboards. This is not the reason why we're building dashboards. We should only look at dashboard when stuff is broken. I know stuff is broken. Now I'm going to look at the dashboard because it's going to give me a perspective. It's going to give me a view on why, like, maybe something that could have failed. When I want to look at pretty graphs, you know, we have a lot of pretty graphs. They have a lot of lines, lots of colors. Maybe it's good. Or when I don't have anything better to do. So if you have to look at a dashboard to find out if stuff is broken in your system, you don't have an alert that's going to give you this information. You have failed at building dashboards. Dashboards are for when stuff is already broken and you know it's misbehaving. And then you go there and you look at it. You should not be looking at a dashboard to figure out if there is a pattern that all of your other systems can see. We human beings are not good at patterns. Like, we are going to be fooled really, really easily by any kind of pattern, unless it's a really easy to catch visible pattern. Computers are good at detecting this kind of stuff. So have a computer that's going to do this work for you, not you and your eyes, because we're bad at it. Different audiences require different dashboards. The dashboard that I look at as a developer for the systems that I'm responsible for are different from the dashboards that the ops people, the people that are responsible for the uptime of the hardware machines are going to look, because they don't have the same understanding of the applications that I have. So I have a different perspective, and when I'm building a dashboard for me, I'm building it in a way, but when I'm building a dashboard to another people, to other teams, I'm building it in a different way. I'm giving them information in a way that makes sense for them because they don't understand all the metrics that we're collecting, and they don't understand all the details of the application that we're building. So if I go to another team's dashboard to get information from it, and it's very, it's full of stuff, full of information that none of them make sense to me, it's useless. Doesn't have any value for me. So when you're building dashboards, think about what are the people that are going to be looking at this dashboard. And most importantly, be direct. Most of the time when we're looking at a dashboard, it's because there's an outage going on. People are crazy. They're complaining on Slack. There are customers creating tickets, and people are just like, oh my God, we're on fire. So be direct. Make it easy for people to understand what's going on in the system. And please add comments to your dashboards. Please, for the love of God. Add comments. Make sure there are comments on your dashboard. Because maybe the graph, you're looking at a graph, and you're like, yeah, this makes a lot of sense. But for everyone else, it doesn't make any sense. It's really hard to understand what's going on. So most of the applications that allow you to build dashboards are going to allow you to have, comments. So make sure there are comments in place, and the comments are going to really say what's going on and what data people are looking at and what does it mean. What if, if one of these numbers are going overboard, what is the actual effect? What is going to happen when one of these numbers is going overboard? So make sure when you're building this kind of stuff that the people that are going to read the dashboard are actually going to understand what's going on. A really good way of doing something like this is that when you build a dashboard, get someone not from your team to have a look at it and explain what's going on in there. If they can't explain what's going on, then it's a bad dashboard. You need more comments, you need more explanation, you need more context and details so that people can understand what's going on in here. So make sure that when you're building a dashboard, you're not looking at it only from your perspective, from your team's perspective. Because your team actually understands what's going on in the application. The other people that need to consume this information might not. So the people that are actually going to consume this information are the people that should be looking and should be giving you feedback on what's going on dashboards. So remember, dashboards are not for you to be looking because they are pretty. They're for people to look when something is going wrong and they want to understand what's going on in the system. And always think about the questions you're asking. Maybe one single system is going to have multiple dashboards. We have one of our main systems has 4 different dashboards for 4 different teams and from 4 different questions. So make sure that when you're building a dashboard, you are actually answering one or multiple questions that people actually have. Just don't show the metrics in there and just have, oh, I have this metrics, I have to show it somewhere in this dashboard. Maybe there's no reason for that metric to be there. Maybe that metric is only for alerts and you're going to be alerted when it breaks. So make sure that when you're building something like that, when you're building a dashboard and visualization for your application, you're actually answering real questions that people have about your system. So make sure it is useful and it's actually doing something for everyone else. And that's it.